Power School Learning. This calendar is super useful if you're absent. If you click the links, there's your homework, blank copy. If you're home and you're absent, you can print it and you can watch the video lessons. The video lesson is also on here. Okay, you can see right here it says YouTube video lessons. Here's the playlist. Okay, so you're always more than welcome to rewatch them or watch them, or if you're good, then you don't have to as well. Okay, you do have bell ringers, but I didn't print them, but the bell ringer was very short today. It was just like a question. You'll do it tomorrow. So let's get out our beautiful orange packet of notes. Yay. Okay, and this is, the back of that orange sheet is kind of like a reference sheet for you. If you're getting confused on the calculator, you can always refer to this sheet. Okay, so once we get into that tomorrow, it'll make sense. It's actually not too difficult, but it's there for you if you need it. All right, so let's go to the first couple questions. They're pretty easy because we've already done it already. Fill out each table and graph the function. So we have x squared. Okay, so if we have x squared, we have our vertex points going to be at 0, 0, like we know. Are you good? Okay, 0, 0. Now, you could go in your graphing calculator, which I taught you how to do this, and get your table, but I feel like this one, we don't have to. Because what is 1 squared? Yeah, and what's negative 1 squared? What's negative 1 times negative 1? 1. Okay, so that's, make sure you use those parentheses. Then we have 2 squared, which is 4, and then negative 2 times negative 2 is equal to 4. Okay, that's your quadratic. That's what we did last chapter. So I'm going to go ahead and graph that. 1, 1, 1, 1, 2 up 4, 2 up 4. And it looks like a U. This is what we did just last chapter. And we're going to compare it to the cubic, which we'll talk about in a second. Compare and contrast it. Okay, so this is quadratic. That's x squared. That 2 tells me it's quadratic. What is the domain of all quadratics? Do you remember? Yeah. Negative infinity to positive. It goes forever to the left and forever to the right. Now range, when I was grading your test, range was the one that people continuously get wrong. Bottom to top. I don't have anything, but I start at what y value? What y value? Yeah, 0. And I go up to what? Infinity. Okay. This is where I had highlighters out. We don't really need them today, but interval of increase and decrease. In the beginning, do I decrease or increase? In blue. Decrease. You decrease from left to right. If I put my finger at the arrow and I go down here, you always start at negative infinity, so I'm decreasing from negative infinity. And what x value do I stop? 0. Then it flips when we go increase, because here in yellow, we're going up, 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 and I go from 0, that's supposed to be 0 to positive infinity, because you always end positive. Start negative, decreasing to 0, then I increase from 0 to infinity. Okay, I'll review. What is my x-intercept? 0, 0, and what's my y? Yeah, 0, 0. They're both the x and y. So you can even put a little arrow if you want. This is your x and y intercept, if you did not realize that. Enter. It just means where is it crossing the x and y axis. Intercept. Okay, I'll review from last chapter. I know it's been a 4-day weekend. Your brain might be a little off. We also didn't really do much graphing when we were doing part 2, but part 1 is when we graph. So it has been a while since we've done this. I told you that every chapter is like, it goes graph, then algebra, graph, then algebra, graph, then algebra. Okay, this is going to be mostly graphing. Today is going to be algebra, but mostly the whole chapter is graphing stuff, which some of you like because it's very visual. All right, now let's talk about the cubic. Okay, very similar way that we're going to do this. I always start in the middle. If I plug in 0, 0 cubed is, what's 0 times 0 times 0? 0. Okay, so 0, 0. Now let's plug in 1. 1 cubed, 1 times 1 times 1. 1. Now careful with the negatives. Negative 1 times negative 1 is a positive 1. Okay, that's 2 times. But then I have positive 1 times negative 1, which gets me, negative 1. So you notice the cubic's going to be a little different than the quadratic is. Now let's do 2. 2 times 2 is? 4. Times 2 is? 8. Careful. It's okay. Now you do it again, but we have negatives, so basically it's going to be the opposite sign, which is negative 8. Okay? So let's graph this in. 0, 0, 1, 1, 2, up 8, negative 1, negative 8. And it looks like a little snake. Did you guys ever see a function that looked kind of like this last year? I don't know if you guys do cubics. But it's like a little, I always think of like the Egyptian, like we'll get more into that when we do like transformations and stuff. You know, when you like walk and do the Egyptian. No, it'll make sense when we start doing reflection. I'll start doing more Egyptian-like stuff. Okay? All right. Huh? Yeah. I'll dress up as an Egyptian. You know, like walk like an Egyptian. No one's ever heard that song? Stop it. You guys, I'll have to play it when we do transformations. Okay. Your domain. Same thing. It goes forever to the left and it goes forever to the right. Now the range, you're going to like this one. It's not really hard because look, it goes forever down and it goes forever up. So it also is all real numbers, negative infinity to positive. So the good part, and people like cubics because the domain and range will always be all real. Boom, you don't even have to think. Now, interval of increase and decrease. Let's talk about this. And I want to make sure that we're looking before, I'll make sure everyone's done writing before I move on. If you watch my highlighter, I'm going up, 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 up. I never stopped increasing here. Okay, I continuously went up. I never changed directions and went down. Okay, so I don't even have, I don't even have decrease. Okay, because I'm always increasing. There will be cubics that it does change, but in the parent function it doesn't. Okay, so interval of increase, guess what? All real numbers. It's always increasing, and you can even make a note for that. It's always increasing. And that's why it's all real numbers. Always increasing. Again, cubics, easy, all real number, all real numbers, all real numbers. Now again, this part, the increase and decrease, will change eventually when we get into different types of cubics, but today it won't. The x and y intercept is the same, 0, 0, and 0, 0. Because all parent functions, your x and y intercept should be at 0, 0. Always. Questions on that? Okay, now let's kind of talk about it. Both of these functions are parent functions. We call them parent functions because they are the original. Okay, they're the parents. Okay, when you do transformations, which we did last chapter, that's not a parent function anymore. It says, however, every polynomial has a degree and a leading coefficient. Okay, so the degree of the polynomial is the largest exponent. If you have highlighters, you know that's something important. Okay, the degree of the polynomial is the largest exponent. So if I have x to the 5th power, that's my degree. My degree is 5. If I have x to the 7th power, 7 is my degree, the highest one. Then the leading coefficient, which we've talked about when we were doing quadratics, is just the number in front of that exponent. So is the number in front of the variable when it's written in standard form. It'll make sense here in a second. Okay, So identify the degree and the leading coefficient. So the degree is the highest exponent you see. So if you look here, I have a 3, a 2, a 1, and nothing. There's no x there. So what's the highest one you saw? 3. Okay, so the highest degree, I'll circle it, is 3. Now the leading coefficient is the number in front of that term that you just said. So what number is in front here? 1. And that's it. Yeah, it's just, there's a lot of words, but it's easier when you look at it. Okay, now let's look at this one. I have 2, 1, 4, 3. What is my degree? 4. It's the highest one, and circle it so you remember. Okay, it's 4. Now, what is the number that's in front of that term? 9. And I'll maybe underline it so you know that's where it's coming from. The 9 is the leading coefficient. Okay? Now, standard form just means that you go in descending order, and maybe I'll write it out for you for this one. Standard form, when you rewrite it, you would use that one first. Then you just go in order. The x cubed minus x cubed plus x squared and plus 3.7x. Okay, this is standard form. It goes in order. 4, 3, 2, 1. And all I did was I rearranged it. I took that piece, went there, took this piece, went here. Okay, just rearranged it so it went in order. If I ever ask for it to be in standard form, make sure that you do look at those powers. Not a huge deal, but it is easier to find certain things when you're in standard form. Flip when you're ready so I know I can move on. Okay. So, there's this thing. It's called the fundamental theorem of algebra, and it tells you that a cubic function, which remember, cubic function is just x cubed, if you need to make sure that you remember that. And it must have 3 zeros. Okay, so if I have a quartic function, which is x to the 4th, that means I should have probably 4 zeros. Zeros are just the x-intercepts. Okay, so, and then there's something called multiplicity. It's how many times a particular number is a 0, I'm going to put a little 0, for a given polynomial function. Okay, so there is some times where we talked about, I think it was, on the test, where, I'm not going to don't write this down, but you had something that looked like this. Okay, it was your vertex was on the axis. That would be something with a multiplicity of 2 because it's quadratic. We'll get more into that in a second here. Okay, a cubic function, just because then we're learning about cubics now. Did you guys learn about cubic functions last year? You don't think so? Okay, yeah, this should be somewhat new. Okay, last chapter was somewhat review because you did learn all of the things, even though you might not remember you did. And then this one is completely new. Okay, recall that a 0 represents an x-intercept on the graph. Okay, if I say, hey, the 0 is 5, that means it crosses the x-axis at 5, 0. And the output is 0. So again, that means, just the x-intercept. That's all that means. A 0 is just telling you where the x-intercepts are. So let's practice talking about it. What are the zeros and the x-intercepts of the following? So remember when we did this for quadratics? It was always the opposite sign. This is the part 1 of chapter 4. So what is one of the zeros? What would make this 0? We're going to have to plug in right here. 1 minus 4 is negative 3. I want 0. 4. Okay, so it's always the opposite sign. So this guy is going to be 4. What about this one? Negative 9. Okay, that's where I'm getting it at. Okay, so zeros, you just list them. Like I just tell you what they are. But if I ask you for x-intercepts, you just take those and you make it an ordered pair. For example, 4, 0 and negative 9, 0. Okay, because zeros and intercepts mean exactly the same thing. One's just talking about algebraically, and one's talking about graphically. Okay, so let's do it again. What about this first one here? What's the 0 of this guy? 3. What about this one? Negative 5. What about this one? 3. If that happens, you see how we had 2 3s. You don't have to write it again. Okay? That's what we were talking about earlier when I said it has a multiplicity of 2. That means that it happens, at that vertex. Okay? And then the x-intercepts are 3, 0, and what? Yeah, very good. Not too hard. Again, just a lot of words right now. It's going to be confusing at first because it's new to you. The vocab is new. Okay, you haven't learned about cubics, but you will get better at it. Okay, use the given zeros to write a cubic function. Remember, cubic is x to what power? That's quadratic. Cubic is 3. Very good. Think cubic, 3-dimensional. Cubes, 3. Okay, so that means that I have to have 3. Okay, I have to have 3 zeros or at least a power of 3. Okay, so here's 1, 2, and 3 of them. This should be easy. Now we're doing the reverse. This is what we're doing right now. So if you look here, I had 3, -5. This is how we're writing it. Okay, so we're just going backwards. So the first one, remember it's always the opposite sign, x plus 1. Always the opposite. Okay, then I have what? X. What about this 3? How would I write that? Yeah, -3. And what about the 4? Yeah, x minus 4. And we're done. Okay, that's your function. That's called factored form or intercept form. All we're doing is switching the signs. And you can put it in your graphing calculator and call it a day. Now this one, there's only 1, and that's weird. Okay, because in cubics I'm supposed to have 3. So this means I'm going to have a multiplicity of 3. That means that it like bounces back up. Oop, it's kind of going slow on me. So what this really means, how would I write this? X, what, 2? Plus or minus? -2. It's always the opposite sign. And all I'm going to do is I'm going to take that multiplicity of 3 and put it there, and we're done. Because you need to have, in a cubic function, 3. Look at 1, 2, 3. This guy only had 1. So that means it has to be a power of 3. I'm not really worried about multiplicity. I'm not going to stress too much about it. But it is good to know. Okay. I'm actually going to skip to the next page so that we can take our time and not worry about this next problem. Okay, so go ahead and skip to the next page when you're ready. Okay, here's where I need you to get on your organization caps and really focus on making sure your notes are super organized, because it's actually not a hard topic. It's just you need to be very organized when you do this. And you guys have done it before, but now we're adding something on. So you guys might be used to this. We did this last chapter where you did this times this. Okay, that first outer inner last thing, you called it foiling maybe in the past or distributing. But now I'm throwing this in on it at you. Okay, it's not too hard. You just have to be organized. So the very first step, I always just kind of take a look at my problem before I do anything. Always. If you look here, I have 1x, 2 x's, that makes 3, and 4. That means I should have at the very end x to the 4th power when you're doing this distributing. And I'm going to write that off to the side. I should end with x to the 4th power somewhere. If I don't, something went wrong. Because again, look, 1, 2, 3, 4. 1, 2, 3, 4. So that means it's a good way to kind of just know what you're going into before you start. Okay. This is the part where people get confused because they take that -2x and they multiply it to everything. But we're just going to multiply it to the very first 2. It's kind of like if I covered the x plus 5 up and we were just distributing. So I would get -2. What is x times x squared? Remember, you just add exponents. X times x squared. Yeah, x cubed. Maybe make a note for yourself if you don't remember. Add exponents when you multiply them. Okay, -2x times -6. -2x times -6. What do you think?
12x.
Good. Plus 12x. And we're done with this guy in purple. in black, I'm just going to bring down the x plus 5 because nothing changed. Okay, so all I do is I distributed that in. I feel like you guys are okay with that. Questions on that part? Okay, now we do that distributing, which is just multiplication, guys. That's why we're really doing the extra math, and you guys have been making progress when I've been looking at your scores. Okay, so keep practicing that. So in blue, I'm going to take it piece by piece. I have negative 2x cubed times x. So I have negative 2, and then what's x cubed times x? Yeah, x to the 4th power. So the way that you say that, because I feel like being juniors and being smart individuals that you are, being able to verbally say it, juniors and seniors, okay, is great. X to the 4th power, that's how you say it, okay? Now, there's no like cool way to say it like x squared, x cubed. It's just x to the 4th power. Same with the 5, like if it was 5, x to the 5th power. Okay, now let's do it again. Negative 2x cubed times 5. What do you think?
Negative 10x.
Yeah, negative 10x cubed. Very good. This guy's done. Okay, we're done with him. Sometimes people like to cross it off to make sure that you know that you did it. You don't have to. Sometimes I do it to make sure that I took care of it. Because all you're doing is you're taking each one and distributing it to each one. It's like if I covered this up and just distributed it in. Now I'm going to cover this piece up and distribute it in. It's like the same thing that we just did in the beginning, but you're taking it piece by piece. Okay, so now in green, I have this guy, 12x times x. 12 times 1 is 12, I know that. But what's x times x? X squared. Keep those x's in. Okay, do it again. 12x times 5. All you're doing is you're multiplying the numbers. What's 12 times 5, either in your head or in your calculator?
60x.
Good, plus 60x. So I'm going to pause there and ask you guys if you have questions on where any of those came from. And you're taking each piece. I took this guy first in blue, and I multiplied him to both. Done with him. Took the 12x, multiplied him to both. Done. And if you look, it goes 4, 3, 2, 1. I'm done. Because it wants it in standard form. Sometimes you might have like terms and we'll combine them. But in this situation, we're just done. It kind of looks like a claw. Like if you're like, you know, Krusty Krab. Yeah. Claw. No? I'll draw it prettier next time and it'll look like from SpongeBob. I'll have Joe draw, his name's Krusty Krab, right? Okay, I thought I was crazy. Anyways, I call it the claw. Any questions on that piece? All right, let's look at this one. Now this one kind of looks similar. It's going to be a little bit harder. But again, if you're organized, it's not that bad. Remember, you add exponents when you multiply. You always multiply the numbers on the outside and then the variables. If you look here, this is the weird thing that I see. Because of this guy, and I would circle or highlight it, we have to just rewrite it. Because remember, like if I say what's 2 squared, you do 2 times 2. Well, x plus 1 squared is just x plus 1 times x plus 1. It's the same thing. That looks bad. Redo that. Then in black, I'm just going to bring down the x minus 4. That's all I did. I just rewrote it. Nothing crazy, just rewrote it. Questions on that part? Okay, again, staying organized. Now, I'm going to pretend in black that this guy's not even here for a second and just focus on the first part. Just like we did before. You take each piece, multiply it to both. Each piece, multiply it to both. So here we go, and be very organized with this. In purple, x times x. X what? Squared. Because look, I have 1, 2 x's. Okay, remember you always add exponents. X times x is going to get me x squared. It is 1x squared. Okay? That guy's done. Now I'm going to take him again and multiply him to the last guy. What is x times just 1? Yeah, 1x. Or just x. We're done with him. Okay, in green, this guy's gone. I'm just going to take the 1, distribute it into both of them. What's 1 times x? Good, just x. And then what's 1 times 1? Careful. 1. I think you add them. And then in black, everything else is coming down. The x minus 4 is kind of just trailing along. He's going to come down and we'll work with him later. Make sure you we're very organized with this because this one's going to be a little bit longer. Okay, now look, just in the very first group, just focus on the first one. Is there anything I can combine? Yeah, the 2x's, and if you have a highlighter, great, get it out. Or maybe just underline so you know that that's what we did. If I have 1x and another 1x, how many x's do I have? 2. Okay, so this is going to become x squared plus 2x now plus 1. In black, everything else is just coming down. I didn't do anything to it. Okay, all I did was I combined like terms. Okay. This looks super scary and complicated, but it's not. Remember what I was telling you guys. Every piece that's separated by like a plus or a minus sign here needs to be multiplied to both of these. So what does that mean? This guy needs to be multiplied to him and him. This guy, 2x, needs to be multiplied to the x and the negative 4. And then this guy also needs to be. So it's not hard math, it's just staying super organized. Again, each one of those pieces needs to be multiplied to both. So here we go. Now it's going to get a little crazy with our arrows. In green, what is x squared times x? X cubed, very good. Questions on that one? Remember, you're just adding exponents. If that's a squared and that's a 1, when you add them, I get 3. Do it again. X squared, hold on, x squared times a negative 4. 4, yes. And then I heard a squared 2, yeah. So negative 4 x squared. Because if you look, you can't really multiply them because they're different. That's why the negative 4 kind of just comes out. That guy's done. Sometimes I like to cross him out just to make sure that like it's gone. Maybe don't do it on your notes so you don't like get confused. But like I know he's done. I multiplied him to both over. Okay? Now let's do it in blue. I have 2x times x. 2x squared. Don't forget those x's. Again, how are we doing this? X times x, when you add the exponents, you get 2. Okay? 2x times negative 4. So what's 2 times negative 4? Careful. Negative 8. And the x just carries down with it because it doesn't have an x to multiply to. This guy's gone now. Do you see how I'm just going in order, just taking it piece by piece? I know this is hard. Now, last one. Again, I know that this could get kind of sloppy, but you should be super excited when you have a 1 because it's just whatever you have. Because 1 times, that's supposed to be purple. 1 times x is x. And then 1 times negative 4, negative 4. This guy's done and I finished. If you crossed all of them out, you know you did it all. Okay, I know that's a lot. But it's really not that bad when you just take your time. You take each piece, multiply it to whatever's on the other side. Now here we go. Let's figure out if there's anything that's the same. So in yellow, this guy right here, these x squareds are common. In blue, I have negative 8x and a positive x. So I have to combine them and then I'll be done. Okay, so my very last step. Bring down the x cubed. What is negative 4x squared plus 2x squared? Or what's just negative 4 plus 2? Negative 2. Negative 2x squared. So these guys are going to be added together. And then if you don't have a highlighter, sometimes underlining helps. Now again, when you're just combining, you're just doing what it says. So what's negative 8 plus 1? Good. Bring down the -4 and we're done. Okay, yeah, that was a lot, but when you take it slow, because I won't assign too much, it's not bad. It's just a lot of multiplying. Use your calculator if you need to. Okay. Make sure everyone's got that down. Okay. I want you guys to try C. Okay. C looks just like letter A. So it's just like letter A, but a little bit easier actually than letter A. Okay, C is a little bit easier. I want you to try it and see how you do. And then I will end with you on the last one just to make sure that you're getting it. Take your time. Remember, when you take this X, you distribute him to these two only. You do not distribute to this guy. He's kind of like off to the side for a second. So that's kind of your first step right there. Work together, work alone, whatever helps you. First, outer, inner, last. Do your first term, your outer term, your inner term, your last. Yep. So the step you go to anything, you just carry them down. Yeah. Okay. And the other group's in parentheses too. So now they're a group. Yeah. Now we do what we did here. First, outer, inner, last. So you take the first term, multiply him to both. It's a big distributing problem, basically. At least make sure that you got the first part right. Okay, you're just distributing it. X times X, when you add them, look, 1 and 1 gets me 2. And then X times 2 is just 2X because the 2 doesn't have an X to multiply to. So hopefully you at least got there so far. Above is the next kind of step. I kind of got you one way. So if you want to check as you go. Okay, in blue, remember you're just taking the x squared, multiplying him to x, which gives me x cubed. X squared times -3 gets me -3x squared. Then that guy is done. I'm done even looking at him. He's done. Then I go over to 2x and do the same thing. Okay, so now in purple, you're fine. Okay, and kind of slowly check your answers. It's when you think of it more as like you're taking each piece, multiplying it to both, taking the 2x, multiplying it to both. You can think of it that way instead of this big, huge multiplication problem. You're distributing one guy and then the other guy. Do you have questions on just this part so far? We only have one more step left in this problem. Okay, if you would have stopped there, great. At least you got to this point, and I'm happy for you. But you could combine like terms here in the middle, which gets me x cubed minus x squared minus 6x. because -3 plus 2 is -1. And I'm done with that. Yes?
If there's like terms to combine, do you have to combine them or are you able to leave it?
You need to combine them, yes. Yeah. Because you want it in standard form, the simplest form that you can go. Again, standard form, 3, 2, 1, we're good to go. What was I going to say here? Okay, remember what we talked about earlier. You know, this one should have had x cubed, because look, there's 1, 2, 3 x's. So I should have ended with an x cubed. That's how you know you kind of did it right. I want to show you a way to make sure that you did it right. If you're at home and you want to make sure that you're doing it right and don't want to rely on my key, I'm going to show you an awesome way, and on a test too, you won't have a key to look off of, how to know that you did this right with your calculator. So you need your graphing calculator. I'm going to show you with a cool way for you to know if you did it right or not. Okay, so we're going to go to y equals, and we're going to type in the original one that we had. So we had x parentheses. So I had x parentheses x plus 2. Close it up. The other one is x minus 3. This is a cool way for you to figure out if you did it right. Go down. In the second one here, type in what you got. What was your answer? Okay, so our answer was x cubed, x caret 3, minus x squared, minus 6x. So the very first one I typed in the original. The second one I typed in exactly what my answer was. Okay, now I want you to watch what happens. You don't have to press graph in yours right now. But if you watch mine, I'm going to press graph. And what's nice about yours too is that they're colored. So here comes the blue one. That was our original. Now look, the red covered it. It's the same exact problem. They equal each other. It should be the same. So you got it right. So did you see that, how it went blue then red? Okay, if you have a different line, let's say it goes like this, then you know you did it wrong because it has to be equivalent. It has to be equal to. Okay, so that's how you know you did it right on a graphing calculator. Okay? Like if I changed right now, like for maybe like you just combine like terms wrong and you put, hold on, come here, come on. -2x squared instead. Let's just say I did that. You'll see what happens. Okay, here comes the blue one, and then the red one is different. It's not the same line. That's how you know you did it wrong. But you're close. That means you're close. Look how close it is. Okay, if it's like completely way off, then you know that it's a lot of things happened here.